we're going to look at actually graphing higher order polynomials today. There's a quick review of what we learned yesterday. So I'm going to go through that really quickly because I think we did a good job yesterday and you have it in your notes. But basically, like I was saying, in order to graph these things, we need to find the x-intercepts, the y-intercept, and then use the knowledge of the general shape to get a sketch. Okay, we're not going to worry about maximum and minimum or relative max and mins. Okay, so this was basically the review from yesterday. Okay, so if you want a very linear table where it's like degree 1, here's the end behavior, right? We noticed that the odd degrees have the same end behavior as lines. So that's what I remember. Okay, so if I have a degree 3, I'm like, well, if it's a positive leading coefficient, it's like a positive slope, and you see how it's got that same end behavior here? Okay, so that was what we did yesterday. So I'll just put it up on the screen for a moment. So if you're on YouTube, you can basically just pause it. You can pause it here and look at degree 4. Pause it here, look at degree 5. They generally don't get you to go much beyond degree 3 or 4 for graphing on the exam. Okay? Let's quickly do some matching. So there's 4 graphs, 4 equations. Let's see if we remember. Let's see, let's just call this A. We'll call this one B. Let me see, I'll make it the same as my note so I don't make a mistake here. Okay. We'll number them. I'll use red. So just so we're all the same, we'll call this 1, we'll call this 3, this will be 2, this will be 4. So let's start with number 1. It's quintic, so this is odd. Okay, and it's got a negative leading coefficient. So that's going to be like what kind of line? Negatively sloped line. Negatively sloped line would look like this. So we're going to be looking for something that has maximum 5 x-intercepts. It's definitely not this one, right? Because we're starting down here. We need to start up here. It's definitely not that one because, again, we're starting down there. This is an even function because it's got that parabola type shape. So let's see. Starting up here, ending down here. So that looks good. Do we have more than 5 x-intercepts? No, so this is definitely graph number 1. I see a hand up back there.
Yeah, I need to go clean my car. So.
Oh, okay. Yeah, go to the office. They got stuff for that. Okay. Let's look at number 2. So it's even degree. Leading coefficient is positive. So we're expecting what kind of line for slope? Positively sloped. I'm wrong. It's a quadratic, right? Yeah. It'll be like an x squared. So we'd be looking for a positive parabola. So it'd be up in quadrant 2 and in quadrant 1. So that one, this is definitely not it. This is down. So that's a negative leading coefficient. Here's one that has a positive leading coefficient. Okay? So this is graph number 2. Is that okay? Yeah? Okay, number 3, so let's see, it's odd, and it's got a positive leading coefficient. So you'd be expecting something like a positively sloped line. There it is, right? Positively sloped line to be like this. So starting here, ending here, this is certainly number 3. Okay, and then process of elimination, like this would be 4, but let's just double check and make sure that everything's making sense. Even degree, and it's got a negative leading coefficient, so that would be like a negative parabola, like y equals negative x squared, it'd be like that. And as you can see, it's got that same end behavior, so that's definitely number 4. Good. So now we're going to basically start graphing these bad boys because we know how to factor them, which means that we can find the x-intercepts. Y-intercept, you're just plugging in x equals 0, and then you have your end behavior, so you have everything you need to graph. Again, these notes are just reviewing what we did yesterday. So it's talking about that language, right? Like that notation that I was telling you about that they use in the exam. Okay, so we generally think like as x gets really big, what happens to the y value? Okay, so the possibilities you say, hey, as x goes to infinity, y either rises, which means it goes to infinity, or it falls, which goes to negative infinity. I prefer using this notation on the exam if they ever ask you, okay? And then, again, rises would be this, falls would be that. So right here, there's a question that says, for the following example, describe the end behavior. So we should just add the little arrowheads on the grade 12 pre-calc exam. You'll lose half a mark if you don't put the arrowheads on. This textbook doesn't have them, so it's just a quirk. But let's talk about the end behavior here really fast. So you can say as x approaches positive infinity. So basically, as we go more positive for x, what's happening to our y values? Getting bigger or smaller? Smaller. So you say as x goes to positive infinity, y gets smaller, it goes to negative infinity. And then you would say, all right, as x goes to negative infinity, so now we're looking on the left-hand side of the graph, y is shooting up, so that means y is going to positive infinity. And that's one way that you could describe the end behavior. Or you could say it in English. So you could say as x gets, as x goes to positive infinity, you would literally just say this in English. You would write it out. So you'd have two sentences, okay? All right, let's see if we can get to the graphing part. This is just a table that summarizes end behavior. So you can take a moment to review it on your own time, but it's everything that we've been talking about. So it just has the leading coefficient. If it's positive, here's the end behavior of the graph for odd degree, okay? So it's got odd and even. Again, I just like to think of, whether it's a parabola or a line type end behavior. But it's all there for you, so if you want to take a look later, you certainly can. All right, this is just a quick blurb on local max and mins. And again, we talked about this yesterday, so I'm going kind of fast. We don't graph them, so we don't worry about them. In grade 12, okay? Take calculus if you're really excited about local max and mins, okay? So. But we just realized yeah, they're there. Okay. So, how do we graph? So what do we need? And I've already said, all you need, so what do we need to graph? I should say, what do we need for a sketch? So all they're looking for in grade 12, to get a sketch and get the full marks, is you need to label your x-intercepts, your y-intercept, and connect them with the correct shape, with the correct end behavior. That's all they're looking for, those three things. Okay, so you're not looking for local max and mins. You're just looking to get the correct end behavior, the correct x-intercepts, and the correct y-intercept, and then you're good to go. Okay? All right, so I think finally, boom, let's graph this one. I believe we even factored it at some point, but I'm going to take you from the beginning to the end, getting a sketch. Okay? Now, this one here, always check and see if there's a greatest common factor. Okay? Does this one have a greatest common factor you can pull out? Yes. You can pull out x. So, you're going to pull out an x. You're happy because then now that's an easy thing to factor. You don't need to do any synthetic division. You know it's going to look something like this. Just find your two numbers that multiply to -8 but add to 2. So what do we got?
4,
Positive 4, -2. And now, let's go and find the x-intercept. So I like to label my work. So I'll write x-intercepts, y equals 0. I should really say f of x equals 0. Okay? So I go 0 equals... Now as far as work goes on the exam, this would be plenty. If you want to just say, okay, x equals 0, x equal -4, and x equal 2, that'd be fine. So you can just say x equals 0, comma, -4, comma, 2. And then I would go plot those on the graph. So here's 0, here's 2, and here's 1, 2, 3, 4, there's -4. And then I would label, okay, well I need my y-intercept, so that's when x equals 0. And you don't necessarily need to show the work, but if you go back to the original function, anything that has an x becomes 0. So 0 plus 0 plus 0, what's your y-intercept? 0. So you can just write f of 0 equals 0, and that would be good. And we already have an x-intercept of 0, that's also our y-intercept, so that's done. Do we need anything else? There's one more thing we need to graph this. We need to think about the end behavior. So you don't have to write it down, you could simply start sketching it, but because it's our notes, let's just write down end behavior and think about it for a second. So you go back to the original and okay, it is odd degree draw a degree with a positive leading coefficient. So that'll be like a line. Now, if it's a positive coefficient, your end behavior will be something like this, like a positively sloped line. Do we agree?
Yeah.
So we're going to start down in quadrant 3, and then we need to end in quadrant 4. So you just need to keep that in mind for when you're sketching. So we need to start somewhere down here. And this is where they don't care where you start. As long as I'm starting down here, so I'm just going to go and kind of just go like this. And then I need to connect the dots. I'm going to go through there, I'm going to go through there, I'm going to go through there, and I'm ending my graph over here. And that would be good enough for a sketch. The reason we tell you about the local max and mins is because we know somewhere in here there's going to be a local max. So that's why I came up a bit and went down a bit. There'll be a local min, and just like that. And you're done. That's it. You got a sketch. This would be like a 2 or 3 mark question, and you would get 3 out of 3 or 2 out of 2. That's it. That's all there is to it. Questions? Great. Let's do another one. Maybe this one will have a bit more work involved. I'll make it a bit quicker. Generally, if they were going to get you to sketch one of these, they would likely tell you one of the factors to save you some time. So, they might say, like, sketch this graph if x minus 1 is a factor or something like that. So I'll just add so x minus 1 is a factor. So now we know that we can start doing some synthetic division. I think I'll do that on another page. So I'm just going to write x minus 1, so a would be 1, and let's go ahead and do the division. I'm going to grab the coefficients, so it's 2x to the 4 minus 1x to the 3, and then it's minus 14x squared, and then 19x, and then the constant term is 6. So let's see what happens. Bring that down. That times that, you get 2, you get 1. And you get 1, so you get negative 13, so you get negative 13 again, so you get 6, 1 times 6 is 6, so you get 0. So now we know that we have, okay, x minus 1. Starting here, what's going to be the degree on the x?
2x.
2x to the 3, and then 1x squared, and then negative 13x plus 6. You'd have to do the whole process again. Let's try x minus 2. Right, so you're looking at the 6 and you're saying, well, plus or minus 1, plus or minus 2, plus or minus 3. One of those would work. Let's try x minus 2. So that would mean a is 2. And I'm really liking this new method that someone suggested to me, where they said, well, I just like to go straight to the synthetic division. Because then if it works, I have the work. I have to check anyways. So let's see. So 2 times 2 is 4, you get 5, you get 10, so you get negative 3, perfect. So you get 0, so now we know we got x minus 1, x minus 2, and then starting on x squared, 2x squared plus 5x minus 3. And now that one you can use some decomposition on, which I'll encourage you to try out on your own. In the interest of just getting this done, I will just give you the answer I got. If you still can't do decomposition, I'd say go back to grade 10. But also, if you're having trouble, come see me at lunch or something, because we got to get that fixed for you ASAP. Okay, so there it is. This is the one we're going to graph. So now we can go and find our x-intercepts right away. So x-intercepts y equals 0. So basically, you're just going to grab each bracket, set it equal to 0. So you'll get x equal 1 from that one, x equal 2 from that one. From this one, you'll get negative 3. From this one, you'll get positive 1/2. So you got 4 x-intercepts. We'll go back to our little grid. And oftentimes on the exam, they don't give you a grid, like it would just be a blank x and y thing, because it's a sketch, like you don't actually want a grid. But so here we go. We have a grid. I'm sort of going to go 1, 2, 3. So there's negative 3. We had one at 1/2, and we had another one at 1. This is going to be a nightmare. I'm going to do my scale a little different here so that I can space it out a bit. So actually what I'm going to do is I'm going to ignore the grid lines, and I'm just going to label it. So when you're doing a sketch, generally, you would just do something like this. So you wouldn't have any grid lines, and they would actually sort of expect you to just label everything. And they're not expecting any sort of scale. you know, you sort of just do something like that. So now they're labeled. What else do we need? What's easy to find? Y-intercept, perfect. So when f of 0, if we plug in f of 0, what do we get? So this is gone, this is gone, this is gone, this is gone, -6. It'll always be the constant term. So then you would just go down here and somewhere you just label, okay, so there's -6. And now let's think about the end behavior. Can someone close that door? So it's even degree. Okay, with a positive leading coefficient. So that'll be like a parabola that's like y equal x squared. So we're expecting to start up in quadrant 2 and end up in quadrant 1. So for your sketch, you're gonna start over here and then you just need to connect all the dots. So let's see if I can do this. My shadow always gets in the way, so it's, my sketch always looks a little funny. So we're gonna come through like this, hit that, we're gonna have to hit that, come through and end up. I forgot my arrow over here, which would lose me half a mark on the exam. There. So as long as you're hitting all those points, and you're starting here and ending there, you would get all the marks. You could have brought this hump all the way up to here, so I could have went and gone like this and come back down and gone super low. That's fine. We're not interested in the relative max and mins that happen at all. Like you could do the wackiest thing, like go down, go all the way down here. As long as I come through that y-intercept and come through that point, we don't care. We're just looking for the general shape. Questions? Is this pretty straightforward? I mean, I know it's hard. There's lots of steps, but is it making sense? Yeah, sure.
But every curve is marked, right?
Every what is marked?
Curve.
Curve? Well, like you need to have a fairly smooth curve. Like if you,
curve, right? Just 3 curve, because their power is 4. So
the way we generally mark this is like they'll assign so many marks for having the right x-intercepts, and then they'll assign like half a mark for the y-intercept, and then there'll be like 1 mark for the right end behavior, and there'll be like 1 mark for the shape. Yeah, so if you're drawing it and it's all janky and then you start losing that 1 mark for the shape. Yeah. We'll go through like exams and the marking guide. They usually have student examples. It's like I can show you like, oh, here's like a really bad graph. They lost a mark for the shape. So I mean that's all coming towards the end of the course, but even maybe towards the end of this unit. There's one last thing we gotta hit, and we're gonna have just enough time, I think, to talk about multiplicity. Okay, so what is up with multiplicity? So a polynomial equation may have a repeated root. So when you have a repeated root, we start talking about multiplicity. Multiplicity. There's a really funny movie called Multiplicity, I think. Here's 2 examples. So here's something that you can factor and you get x minus 1 squared. So that has a repeated root. Okay? So when that happens, we look at the power of that repeated binomial, and that's the multiplicity. So we say, hey, this graph has a multiplicity of 2. Okay? At the x-intercept 1, multiplicity 2. Great. Here's another graph. This one here, it's a degree 3. It actually factors out to x minus 1 to the power of 3. So we say, well, this one has a multiplicity of 3 at the root x equal 1. So you just solve that and figure out your x-intercept. Turns out that when your multiplicity is bigger than 1, the behavior of the graph at that 0, so in other words, at that x-intercept, depends on its multiplicity. So here's the 2 graphs of those 2 examples we just went through. So this one had a multiplicity of 2 at x equals 1. So here's x equal 1. And when you have a multiplicity of 2, the graph will actually just touch that x-intercept and then change direction. When you have a multiplicity of 3, so here's that x-intercept at 1, the graph will actually really flatten out and go through that x-intercept. So we sort of draw it as like a straight line, but in reality it's just going through that 1 point. But on the exam, if you have a multiplicity of 3, they're going to want to see the graph flatten out. So they'll be looking for that. So if I was to sketch it like this, let me show you, I would lose so many marks depending on the question. So if I just drew it like this, and I just went through, see how I didn't make it look like it flattened out? then I would lose like half a mark or a mark, just depending on the question. So you need to draw it so that it looks flat. So you'll like really exaggerate it. That's really bad. I might lose marks because it looks like I have like a right angle there. Okay. So how does this multiplicity work? Well, this is everything I just said in words. This is the important part. Here's the part you'll want to highlight so that you can read through it later, right here where it says in general. So if you have an even multiplicity, even as in 2, 4, 6, okay, the graph will touch the x-axis and it will not cross it, it will change directions. Okay, so we see it just touches and changes direction. Changes direction. If you have an odd multiplicity, the graph will cross through that x-intercept and add and flatten out. And I'll put flatten out in like quotation marks, flatten out. I believe I have 2 more examples. I'll just give you a moment. And we will talk more about this tomorrow. We'll do some more graphs, or sorry, on Monday. I believe the last example. Even if the bell goes, just hang tight for like 1 minute and we're going to finish this. So there's 2 examples. They say sketch these. Okay? So x-intercepts at 1 and -3. What's the y-intercept? I'll just tell you it's 9. Y-int is 9. So let's just go ahead and do a quick sketch. We got an x-intercept at 1, so I'll just label that 9. This is 1. We got another one over here at -3. This is an even degree.
University both have information booths set up in
Okay, so if you add up the exponents, it's a degree 4, and it's a positive leading coefficient. So we're expecting end behavior that looks like this.
And have a talk with the people there. They will be here until after lunch. Thank you.
Great. Okay, even multiplicity, right?
So please call the office.
I'm expecting a phone call about hot dogs. For even multiplicity, it will bounce back. It'll just touch the x-intercept and bounce back. So we know that we start up here. We're gonna touch it, bounce back. We gotta go through here, touch it, bounce back, boom, done. Let's just take the 1 minute to do this one. Negative leading coefficient. Is the degree odd or even if you add up the exponents? Odd. X-intercept at -2 and 1. This one has an odd multiplicity, so we expect it to flatten out. So we'll go label -2 and we'll go label +1. The y-intercept's -8, so this one's going to have an end behavior like a negatively sloped line, so like this. So I'm going to start here, and I'm going to say, okay, at -2, I need to go through and flatten out. So I need to go through, flatten out. I need to hit my y-intercept. Now when I get to the 1, what happens? It's going to touch it and bounce back, because it's even multiplicity. So it's going to look like this. Do I have the correct end behavior here and here? Yes. So that's how you add in the multiplicity of the graphs, and it's the last thing you need to know to graph them. We'll do a bunch of practice tomorrow, okay? Bye-bye. Thanks for staying.